Blender is a modeling tool for making meshes. So I would be taking two objects, a cylinder and a cone, and I would just make kind of hole from top using the cone. So first I would be translating it towards, rotating it about x-axis. Oh, sorry, x-axis. That's it. Yeah. So now you can just reduce the z. And now I would be applying a Boolean operator on it. The difference. You would be applying difference. You would have applied the intersection too, but yeah. And now we would be selecting an object, like we would be using difference. A minus b is the cylinder and b is the cone. So yeah, you can see that it's already we have got our thing. And now we'll be exporting it as a .obj file. Selecting the location where you want to export it, and making the object C. Now we have to remove the UV coordinate or normal and material, but you would be adding triangle to mesh. The other things we have unselected because they are not required for this assignment. Probably would be required in other maybe upcoming assignments. Now we can save the Blender also. This as in because if you want to make any further changes to this object, you can just directly open this window and save a different .obj file. So we'll be saving this Blender file as well. So this is the same object in from the previous Blender video. So you'll be copying this object and you will be basically taking an intersection. So you can select this object. We go for a Boolean and we do an intersection. Select the object as we render to, and we basically just take a intersection. So now if you see the object, it's as in top it's the same. From bottom also you have this. So this is a new object 3 is working on with. So it has an difference option. It's a intersection also. It's a combination of intersection too. So we'll be working with this one. So in this part I will be showing the features and different modes and stuff. So this is an object when it's selected. So here it gets selected. Then maybe I can click on some other objects. They get selected like here, only here and object 3 and yeah. And if I click here, just click on canvas, no shape selected. And these arrows are the objects which should not be selected even if they are clicked on. So yeah, it says no shape selected and we click on this. So therefore if we select this object and we can basically like, translate it, or this is like z-axis if we are translating it. And suppose if you want to rotate it, you can rotate it about x-axis or y-axis. They calculate another zero angles and nothing. And if say you want to change mode, you can also change the mode. And now it's already selected. You can change to animation mode and click on the 2 points, and you can increase or decrease the speed of animation. And yeah, and we also, if you want to select this object since and we want to animate this, you can just animate it. And it's yeah, you can change to other different modes as well. I mean top view or 3D view, and you can change this view also. So yeah. And if we say that an object we go to 3D mode, you can translate it, rotate it, and do other stuff. So yeah, this is along z-axis, this is along x-axis, and this is along y-axis. You can also like, rotate it along x-axis and stuff. So this part of the video deals with the code walkthrough, and if you want to see the key bindings and stuff, you can just go on to the readme file where there is a proper table for each and every key binding. So if we start with renderer.js, not many changes are made, but we have to change from only vertices where there is obligacy to vertices and indices. So some changes were made according to that, like elements was added, and we had this model matrix, and it was already there, but some of the things needs to be altered in the other transform.js. And we have the view matrix and the prediction matrix, and we update some of the things according to that vertex and indices. So in scene in shader.js, we have this new function draw elements, which basically draws keeping in mind the indices, and there are some other functions like element buffer and stuff for finding the elements. This is an old vertex function. We haven't made anything there, but it was basically used in a little different way. And yeah. Then for transform.js, not many changes have been made, but I've just taken out differently translate x, y, and z. You can just take it as one also. There's a scale, there's a rotation around x, y, and z. Yeah. And matrices needs to be in the reverse order. Basically, for by logic, it should the thing which needs to be done first is written at the bottom. So first we do the scaling, then we do the rotation around z, y, and x. Then we do translation around z, y, and x. Then initially we start with the empty matrix, and we get the So initially we had like a square or values on different classes, but here we can generally just have a uniform class for any kind of mesh object. So some of the objects are not selectable, like the arrows on there. Basically the arrows and other stuff are representing the axis. So for that we used a selectable. We just change it to false in that case. We just stored the original color as well, because in case an object is selected, the color is changed to some other color, so we stored the original color somewhere. This color is the color of the object in that current point of time. So in this case it may change it to black, and we may change it back to the original color when it's unselected. In this name there is date and data. We have vertex array and indices array. So like other normal and other information. Yeah, in this function state as symbol. We have used symbol in this assignment. It was needed. So first. Yeah, so for vertex.js I added two more matrices here, so that you know this is for the camera and stuff, and yeah, so these are the global variables and we are initializing them here. This is like that's a new matrix and projection matrix. These are some logic related. Yeah. So we have some this I, and we decided to three as in this was for top view model, top view mode, and the camera rotation initially is around y-axis. When we change to 3D view, then this is used. And then after we are done with this, we can just set the view matrix using the function locate and use perspective to calculate position matrix. And then we have the speed of the animation here, and the animation mode and some other variable. So for fetching the mesh object, we use this function fetch, and it's a promise function. So we use weights and stuff. We call like this objects double sided arrow, and we call the same double sided arrow 3 times for x, y, and z plus 3 objects. So what we'll do is that we will rotate the second arrow around x-axis or z-axis permanently to get it around the z-axis to get it along y. We rotate it about 90 degrees. So yeah, this is the main animation function solved at regular intervals, and we have added the animation function here. So this is the pi arrow which I was talking about just seconds ago. So we scale it a bit, and then we rotate it by pi by 2 along the z. Similarly with z and the monkey cap and ball withering and the object tree. So when we click on the scanners, it basically executes this function. It initiates here, and this function is getting executed. So if it's in top view mode and animation is 0, that is, will be set in objects, for which we basically have this part. We also set a parameter as in as true. Maybe we can get it later, but yeah, this basically gives us a color, 3 pixels, and we get that color, and we call this function selection by color from the scene. So what happens here is that we treat the color as a kind of a point in 3D, like R, B, G, so it can be X, Y, Z. And we find distance by, if we have two colors, the color of print, and we have a color which was which we got after clicking on the scanners. So it's not necessary that even the decimal values have to be same. So there could be something like 0.3 and 0.3001. So in that case, we basically find the distance between the two, and we select threshold value to get that color. So here's the canvas thing, and we have set the value as 0.002. And for pivot also, we have taken threshold as 0.002, and we basically calculate something known as color distance, very similar to the original x square plus y square plus z square. That thing. We thought it will be always possible. So that's about the color. Yeah. And then there is this for like every time it's rendered, never click on the screen, it's getting rendered again and again. So we follow that Stack Overflow function, which the link to it I will be giving it in the report. That basically led us to we will set the initially it was being 0, 0, 0. So yeah. Then if it's in top view mode and animation mode is 1, in that case we we were using Centroid, but it was not doing that good result. So hence we use current translation X, Y, and Z, and we store that in P0. So yeah. So they're already in world coordinates and stuff, so we don't need to change it. Now for B1, we click on the screen, and we basically store it here. And in that case, we have to use mouse, like basically the mouse coordinates which we get needs to be converted to world coordinates. So these are the different key bindings like mode, arrow, down arrow, and stuff. These all things are there in README in the form of a table report or keys. So suppose we move a mouse after clicking and we move a mouse, we have this distance here, which basically gives a distance like how much the mouse moved, and we can just multiply this by a factor. So yeah. This is the different camera thing. I think it's already so basically I'm like finding an axis about which we are rotating it, and we change the I, we make it a full where on the 1 plus 4 vector, and we transform the vector, we transform the up vector, so it's to just change that view. Now this is click to world thing, which is basically we have the mouse coordinates. You first click it, first change it into click coordinates, and then from click coordinates you change it into world coordinates. So this was a function which was basically used to test if world coordinates are working fine. And this is the animation object. So in animation object, we are basically having some we have a new shape or this selected shape, and the near shape is the same thing. So there's some trivial condition there, and this is the main animation code. So we just calculate A, B, and C with respect to X, Y, and Z. We have basically three quadratic equations. Now if we see these three quadratic equations, we basically can understand that if we just change T and we update it in every animation, like whenever this function, the animation is called, this function will be called. So you can just update this T with some speed, which is controlled by a key binding. So it can be updated every time T will vary from 0 to 1. So if it's less than 1, in that case this function will be executed, and you can get an updated value every time using this. And if it's above 1 or equal to 1, so this one will vary. So if it's equal to 1 greater than 1, in that case the animation will stop. So that was a quick code. So thank you.